Hello everyone. In this video, I'm going to walk you through basics of program control structures. This video is going to cover mostly topics from this handout, program control structures. All right. So let's get to work. I will do my best to keep this video as short as possible. The main idea here is any problem you want to solve in data analysis, data analytics, any business problem you want to solve, usually we go through certain steps. We perform one task and then after another task. In computer programming, there are only three structures that we can or we will follow to solve any problem we have. All right. And by the way, those steps that we follow, possibly one after another one, we call that algorithm. All right. There are three structures that we are going to follow in solving problems. One of them is called sequential, the other one is selection, the other one is repetition. Right. Let's talk about sequential structure first. Sequential, as the name suggests, we are going to follow one line after another one. I'm going to say x is equal to 10, y is equal to 20, AVG is equal to X. Very rudimentary example, divide by 2. So I'm finding average of two numbers and then print. I'm going to use print formatted print. All right. The average of X and Y is AVG. All right. What's going to happen is that a Python interpreter is going to run the first code and then the next one, second one, and the third one, and the fourth one. So this is sequential, all right? There is no skipping of one line. There is no going back to one line, just one after another one, and another one, right? That's why it's called sequential. An average of 10 and 20 is going to be 15, right? We are going to, most of the time, that is the structure we are going to use. However, sometimes we need to do some sort of a selection, right? What I'm going to do, I'm going to first introduce you to a function called input function. Probably you have seen it in the handout, but this input function is used for accepting input from the user, right? Let's use that. Num1. You're gonna get tired of that num1. Num1 is equal to input, enter a number, all right? And that's it. What's gonna happen is that we are gonna show this message, enter a number to user, and whatever user enters, we are gonna save it in num1. I'm gonna enter 20, and that's it. Now, if I show num1, there's a surprise there. Num1 is not an integer, it is actually string. If you don't believe me, type, let's check type of num1, all right? It is a string. Whatever input returns, it is going to be in a string format. If you want to perform mathematics with it, you need to use either int function or float function to convert it to integer or float with floating point, all right? That's exactly what we are going to do. We are going to say num2 is equal to, let's use float of num1, all right? Num1, remember, num1 is a string 20, all right? And give me num2. Num2 now is going to be, you see, it doesn't have those quotations anymore. It has 20, it is 20.0. And what is type of num2? Type of num2 is now is float. Right now that we are familiar with input function, let's use it for learning a little bit about sequential and selection control structure. All right. This is what I'm going to do. I'm going to first accept a number from user and use a if statement to determine if the person passes or fails the course. All right, I'm going to say grade is equal to input, enter your grade, all right? And I'm going to just stay here and say, you know what, turn that into float right here. Rather than defining it in multiple lines, I'm going to just say first accept the input from the user and then convert it to float. My grade now is going to be a float number, 85, and that's it, all right? If I want to see a grade, it is going to be 85.0 because it's a float. All right. Now next, I'm going to say if grade, whatever user enters. All right. I'm going to modify this a little bit. If grade is greater than or equal to 70, all right, then oh, look what happened. I entered, if I said grade greater than or equal to 70, colon, and when I pressed enter, it didn't go to the beginning of the line, it went to 4 spaces forward. I'm gonna count that 1, 2, 3, 4. All right. Um, one more time, when I put colon, all I'm saying is that if line is done, now, if that condition holds, perform these tasks or one task. All right. I'm going to say print pass. It's getting late and I'm slowing down. Print pass. But I also want to, in this cell, accept a grade from the user. So I'm going to run everything all together. Right. I'm going to put it right there. I'm going to accept a grade from user. If it's more than 70, I'm going to say pass. So if user enters 90, it's going to say pass. That's it. But if user enters, I'm going to run one more time. If user enters 15, that condition doesn't hold. As a result, nothing is going to happen. All right. That print is not going to happen. All right. So I'm going to let me run and nothing happens. All right, that is the very first control structure that we have. If grade is bigger than or equal to 70, print pass. Does it have to be just one line? No, it could be hundreds of lines of code. Print 12. Right? Let's run it. 88, and it's gonna say pass 12. Right? It could be anything. It could be you can perform mathematical operations there. That was the very first structure that we have. Next structure, as you can see here, is if else. This is what I'm going to do. I'm going to first cheat and get part of this from here. So accept a grade from user. If grade is bigger than or equal to 70, print pass. All right. But I'm done here. I want to write something else. I'm going to go to beginning of line and say else. That is also another reserved keyword for Python. Else colon, if I press enter, again, it is going to be indented, meaning it is going to be exactly same number of spaces in front of, it is going to go indented, right? Is going to be forward. I'm going to say print fail, right? Does it have to be one line? No, it could be many lines, or a print 2. All right, and let's see what happens. If user enters grade of 95, it is going to print pass. All right, I'm going to run it one more time. If user enters grade of 60, it's going to print fail and 2. All right, this if else is binary. What does that mean? It means that Python either is going to perform or run this block or this block. There is no way that Python is going to run both of them at the same time. All right. There are situations, and many situations, where you might have you don't have that binary structure, but you might have a binomial structure that you have if, then we are going to have elif, which is the short version of else if, and there is an optional else at the end. All right, what does that mean? Let me show you one example. All right, I'm going to cheat again and get part of this code. All right, I'm going to say if grade is bigger than or equal to 90, right, print pass. Elif grade bigger than or equal to 80. Let's see what I did here. I said else if, or elif, if grade is bigger than or equal to 80, what am I gonna I'm gonna say if grade bigger than or equal to 90, I'm gonna print A. Here I'm gonna print B. All right, and how about are we done? You can have as many elifs as you want. Elif grade greater or equal to 70 print C. Does it have to be just one line? No, you can write as many lines as you want. Print as long as they have same indentation. All right, I'm gonna make a mistake here, and you're gonna see that Python doesn't like that at all. Print you passed. You're lucky. You're lucky. All right. Let me mess up the indentation a little bit here. Let's say just one of them indentation is not aligned with the rest. All right, let's see what happens. Python doesn't like it. It says, you know what? This is not, there's something fishy happening here. I don't like what the indentation. So they must be, and you see that there's a red font there. So you need to fix that. If you fix that, I'm gonna keep writing code, but let me run the code. You see that Python is not gonna give you unexpected indent error, right? Grade 90, and it's gonna say A. But I can keep writing. Oh, that's not what I meant. You can keep writing the code. You can have as many elifs as you want, as long as they have same indentation, right? There is an optional else statement at the end. You saw that I run this without else, and it worked. I'm gonna write, oh, not there, here. Else print, what are you doing? What's happening? What's happening, right? Oh, all right. Just for the sake of time, I'm not gonna even touch that, right? It is covered in handout 1. But if you really want to keep that, it's fine, fine. What's happening? What's happening? All right. What is going to happen is that only one and just one of these blocks will be run. If grade is bigger than 90, A will be printed and the rest of these will be ignored. If grade is bigger than, if this is wrong and grade is between 80 and 90, then this block will be run. If grade is between 70 and 80, only this block will be run. And if none of these first 3 conditions hold, just this, when everything else fails, this block will be run, right? You're not going to have situations where all 2, 3 of them run at the same time. No, you're not. If you write your elif correctly, you are not going to have that situation at all. All right. Let me get a grade. I'm going to get a grade of 23 first. And what's going to happen is that it is going to pass all of these 3 conditions, and it's going to write out what's happening, right? What's happening. Let me run it one more time. I'm going to run this one more time. Enter your grade. This time I'm going to enter grade of 84. So it is going to pass the first one, but it is going to stuck here, right? And it is going to ignore the rest. 84, it is going to write B, right? One more time, I'm going to run it one more time. Enter your grade. I'm going to enter grade of 90, and it is going to stop at the first one. It is going to ignore first elif, second elif, and the last else, right? It's going to say A. That sums up our selection. If else, if elif, else, and then that else is optional at the end. You don't have to have an else clause at the end, all right? Now let me go back. There are 2 structures left, for and else, and that is repetition. A lot of times your algorithms involve repeating same thing over and over and over again, right? For those situations, Python offers for and while structure. Let's go to, first let's talk about for. I'm going to say for characters, char, character, car, in Python course, print character. Again, this is the structure for character in Python course. Colon, again, it is indented, all right? What's going to happen is that this for loop is going to go through every character in this string, and it is going to print them one by one character in one line, all right? Let's run it, and you see that Python course, the characters, even the white space is printed in one separate line. The term in the right side of in must be iterable. If you watch the previous video, you have heard that term. Iterable is a data structure, mostly in our course is going to be list, tuple, and string, that you can go through its elements one by one. And as you can see, this for loop is able to go through these elements one by one. Python space course. It goes through them one by one and it prints them. All right. Is it possible to do that with an integer? Let's try it. All right. For, let's say, character in 12, right? Print character. Let's see what happens. All right. It says int that 12 object is not iterable. You cannot go through 1 and 2. Integer is not iterable. If you really want to print that 1 and 2, you need to put them inside quotations and make them a string. Then this one is going to print 1 and 2 for you. All right. Now back to for loop. Here's very common structure for loop. For loop usually is used, quite often is used with a function called range function. I'm going to use 3 different examples to explain that. I'm going to say for item in range of 5, print item. What's going to, print item. What's going to happen is that range is a very widely used function in Python. It starts, you can give 1 argument, 2 or 3 arguments to a range function. Range of 5 means all the integer numbers starting from 0, 0, 1, 2, 3, 4, not 5. All right, 5 is not included. Right, this is going to print 0, 1, 2, 3, 4. 1, 2, 3, 4. All right. Range function, by the way, is also is iterable. As you can see, you are iterating through numbers in that range function returns. For item, here's another way of using range function. In range of 2 to 6, right? Print item. This is going to start from 2, 2, 3, 4, 5, not 6, right? So now I'm giving it beginning and end. It doesn't start from 0, it starts from 2. 2 is included, 6 is not included. So 2, 3, 4, 2, 3, 4, 5, 4 numbers, all right? 2, 3, 4, 5. There is another way of using range function. For this time, let's use I. Doesn't matter. In a range of 1 through 3, fine. 3 to 13 and 4. Print. I used I, right? So this now has 3 arguments. It is going to start from 3. The first one is the beginning number. The second one is the ending number. And the last argument is the step size. So it's going to print 3. Then it is going to print 7. Then it is going to print 10, all right? And then if you add 4 to 10, it's going to be 14, is above 12. So it is not going to print that. So it's going to print 3, 7, 3, 7, 11, and that's it. I'm sorry, I made a mistake. 3, 7, 11, right? If you really want to print the very last number as well, I'm sure let's do a math. So if I add 4 to this one, it is going to be 15, right? If I add 4 to 11, it is going to be 15. But because 15 is not included as a second argument, I need to change it to 16, right? If I change it to 16, it is going to print 3, 7, 11, and then 4 on top of 11 is going to be 15. So it is going to print 3, 7, 11, and 15. 3, 7, 11, and 15, right? That is for loop. For is usually used when rule of thumb is that used for when you know that for fact how many times you are going to repeat that task. right? Here I knew that I'm going to repeat it. I'm going to repeat it 4 times, right? With before running, I was able to say, you know what, this is going to print 3 numbers, 4 numbers. There is another structure for repetition, and that is while. This while loop is a little bit confusing, and it is used when you do not know exactly how many times you are going to run a loop. All right, I'm going to use a little bit of a thought-provoking example for explaining while. All right, I'm going to say import random. All right, I've used this in the previous, I believe, video. This is going to import random module from standard library of Python. I'm gonna say num1 is equal to random data random. What this is going to do, this is going to generate a random number between 0 and 1, and it is going to assign it to num1. What is the value of num1? I do not know because it's a random number, right? This is the structure I'm going to use. I'm going to say while num1 is less than 0.7. Why 0.7? You can choose 0.9. You can choose 0.5, right? While num1 is less than 0.7, print num1, right? And again, say num1 regenerated is equal to random data random. Don't panic, I'm going to explain this. First, I'm importing random module from Python's standard library. Then I'm generating a random number between 0 and 1. I call that num1. First, I'm going to compare num1 with 0.7. If num1 is less than 0.7, I'm going to print it, right? And then I'm going to run that function one more time. This is going to generate another random number between 0 and 1. I'm going to go back and check that loop. The new random number, if it is less than 0.7, it is going to print it again, all right? If not, it is not going to print it. This loop is going to repeat as long as random numbers generated are less than 0.7. If the moment that the random number is 0.7 or above 0.7, it is going to stop. How many times it is going to repeat, I don't know, right? Let's run it. It ran twice, right? If I run it one more time and it's printing those numbers, right? They all are below 0.7. If I run it second time, I don't know how many times it is going to run, right? Nothing. It didn't print anything because the very first number that it generated, it was above 0.7. You don't believe me? Let's take a look at it. Num1, 0.99, all right? Let's run it one more time. This time 3 times. All right, let's run it one more time. This time, look, run probably 10, 11 times, and all of them numbers are below 0.7. So again, this is a while structure, very similar to, in terms of a structure, similar to for. So you have to write while, your condition, I'm sorry, similar to if, sort of, and then colon, and then you have indented block. Let me go back up here. We talked about range function, iterable object. We talked about this, all right? We talked about iterable object. String is an iterable object. Range function generates iterable object. There is one topic left, the important one, augmented assignment. Let's talk about that, and then I'm gonna wrap up this video. Let's say I want to define a number, num2 is equal to 10, and I want to add 5 to this. It's very simple statement, right? The one way of doing this is num2 is equal to num2 plus 5, all right? Let's see what this does. First, what Python does, first looks at the right side of this equality and says what is value of num2? It is 10. It is going to add 5 to it, 15, and it is going to store it at num2, right? And if I say, you know what, give me value of num2, it is going to give me 15. This is fine, but this is so not Pythonic. This is ugly. This is, if you write something like this, you are going to lose points, right? Do not do this. Python, and again, there is a even technical reason behind that. What this does, technically, it creates multiple objects. What we are going to do instead of this is a much cleaner, nicer way of doing same thing. Num to 10, I'm going to say, oh, num2 plus equal 5. That's simple. All right. I'm going to say, you know what? Add 5 to whatever num2 is and store it at num2. If say give me a value of num2, it is going to be 15. Right. Um, this is called augmented assignment. Whenever one of the operators is in the left side of equality, is it just plus sign? No. Num2 minus equal 100, right? Value of, let me just to be clear, a little bit cleaner, num2, again, define it to be 10. So I define it 10 and then I subtract 100 from it. Num2 is going to be 90, right? I'm sorry, minus 90, minus 90. Can I, instead of minus, can I use multiplication? Yes, you can use multiplication as well. Any of those operators that you need to put it to the left side of equality, and we are going to call it augmented assignment. We are going to use this quite a lot. It is part of your handout, and I will cover that again in class. But if you have any questions, you can also reach out to me. All right. And there is also one topic left, and it is covered here called, let me see, error versus exception. Uh, I'm not going to cover it in this video, but I think it's a good idea for you guys to go over it. I will do my best to cover it in class, right? With that, I am going to stop. If you have any questions, just let me know. All right, take care, guys.